Hey guys, so we've had some questions about BASLOAD recently, so I thought I would just dive in with an example. So I found this old basic example in an old IBM manual actually from 1975. It still works here on the Commander X16. Um, so let me just type it out. Alright, simple little program. I'll run it, make sure I typed it in right. Okay, simple, straightforward. Now to show a few features, just in case some people aren't familiar with how to edit just regular basic programs. On these CBM-based systems, so CBM's Commodore Business Machine, starting with the Commodore PET, they had this style where you just drive the cursor around and start editing your software. In this case, I just happen to know on the Commander 16 there's this space keyword, SPC, that will make a bunch of spaces for you. And that's all this for loop is doing, is it's just deciding how many spaces to make. So I can get rid of this for loop and just say C equals, how many I want. And then I can print space that many. Remember to keep the semicolon that keeps, after the print, keeps the cursor basically on the same line when the print finishes. And since I no longer have the loop, how do I get rid of a line number in this basic? You just space blank it out. It is important, remember, to press enter. Don't modify it and then just move the cursor away. You want to make your change and then press enter to commit that change into memory. So now if I type list, you see this short little program has been revised. Line 80 in particular is gone. And now when I run it, it's still the same result, right? That space keyword is working. So now I want to convert this to BASLOAD. Nice simple little example. Actually, there's one more thing I want to show. One thing you'll hear us talk about on the CBM systems, you'll hear about quote mode. And it can be frustrating at first. When you type a quote, you are now in quote mode. And people get frustrated, they get stuck. How the heck do I get out of that? What is the thing doing? As I'm moving the arrow keys, it's putting in the code that's the equivalent of moving around in the arrow key. Some people like that, some don't. Once you get used to and understand what it's doing, but to get out of quote mode, you basically just type another quote, and now I can move around. So it's kind of like a toggle. As soon as I type a quote, I'm now in quote mode. And then you just type quote again to get out. Now I don't want to save what I just did here, so I'm just going to move the arrow, the cursor off. If I type list, and you see my changes weren't saved there because I didn't press enter on that line. So that's just something to be aware of about quote mode. If you have the Commander X16 kind of official keyboard, you'll see a lot of symbols on the keyboard. And that's what those symbols are for. When you're in quote mode, it'll start applying those symbols, including the color code changes. So before I convert this over into BASLOAD, let's switch gears a little bit and let me talk about Tokenized BASIC. All right, nowadays, almost all source code is in ASCII text, or some people will call plain text. Whether that's C source code, Java source code, JavaScript, C Sharp, even QuickBASIC, all modern source code is basically text files. But that wasn't always the case. BASIC was developed in the mid-1960s at a time when even having 4K of RAM was a luxury. And so they had to be very efficient in how they stored code. And so what they came up with is, I wouldn't call it a compression, but it was just a tokenized form. Um, so in this chart, you see a few things going on. We have one line of BASIC at the top. It's line 10 where I store ZZ, an integer, and assign it to an integer value. Then a compound statement, and I print the value. So you run that program, and the value, as expected, is printed out. You'll notice this space in front of the integer. and that's a placeholder for the sign value. If it was negative, you'd see a negative sign in there. And then another neat thing about BASIC is it has this immediate mode, and you can write a line of BASIC without a line number, and it'll run that one line of code immediately. And so this line of code, I'm using a for loop to kind of peek through memory and show the contents of memory, which shows the tokenized form of this program. Tokenized BASIC is partially plain text. If you view it in a hex editor, you might coincidentally see some values that look familiar. But one prime example is like the print keyword is it's not stored as the letters print. It's represented as this one token, hex value 99. And some other aspects here, the code in BASIC kind of has this little header for each line of code. The first part of that header is a pointer to the address of the next line. That becomes important because remember, BASIC is an interpreted language. If it can skip lines of code, it can do so by basically doing a single linked list. I've seen other variants of BASIC where they have a bidirectional linked list, but in any case, on the CBM systems, they have one address pointer. Keep in mind the address, the bytes are reversed from how we would think of it. Then after that, after the address, it has the line number, and in hex, if you're familiar with hex, 10 is equal to line number 10. Notice it provisions for 2 bytes there, so that's why your programs can't be larger than, I don't know if it's 32,000 or 65,000. I don't know if the line numbers are unsigned or not. I think it's unsigned, so it's probably can't be larger than, you couldn't have line number like 40,000, for example. You certainly couldn't have like a line number of 100,000. There's just no room to store that kind of line number. Then that's followed by the code sequence. So ZZ with the percent sign indicating that it's an integer is stored like this. If you look up ASCII code, really the PETSCII codes, you'll see the 2 letters there, 5A for ZZ, and then the modifier of what type of declaration that it is. B2 is the token for the assignment operator. Then you see our numeric value, which coincidentally, looks in hex a lot like our decimal value, 32767. Did that for a reason. Then 3A is just the compound, the colon operator. Then print, as we talked about, isn't stored as the full word. It's just 99 with a space, and then the value the variable that we want to print. Then each line has a null terminator at the end, or a marker saying this is the end of this line. Then, as you can see at the end of the program, it's code followed by data, and these variables, if you pay attention, DA, the high bit is just set from 5A, so it is still the same value. The same variable ZZ, the high bit is set just indicating that it's an integer version or storage type. And so you see the nice traditional unsigned integer representation of that value. Whereas later in our immediate code, we have the value, the variable II is stored in the 40-bit floating point representation. Remember, we were peaking the value as we were incrementing the II value. So this somewhere in this loop is what this value corresponds to in the immediate mode. But the point is, or the main takeaway here is that this is what we're talking about when we say tokenized BASIC. The code content that you typed is literally not stored as is in RAM. It's stored in this kind of, with a header, binary packed representation. This is a very small example. You see, it's not saving a whole lot of bytes, but in a longer program, it starts to add up, where you have tokens representing the major operations rather than spelling out the original keyword. And so when you do a list, keep that in mind. It's parsing this code sequence as it's listing each line. It's not, you don't get it for free. That it's just listing the plain text in memory or from a file. That's the other thing about these boot up to BASIC systems, that they can function as you turn on the system, and imagine it doesn't even have a file system, and so you can still function with your basic parser, because it's packed all this in memory. It doesn't have to really store all this to a file. Now notice down here, the Commander X16 has these pointer keywords, so it has a utility here to search the code space and find the address of your declaration. So that's pretty nice. So you can confirm the addresses. And yes, since you can poke straight to this RAM, you can manipulate it in other ways outside of the standard basic keyword calls. So that's just that discussion talking about tokenized basic versus plain text. You know, we almost always assume that all of our code is in plain text, and that's not the case with basic. It's in this packed form. Each system that has basic, it's slightly different maybe on what token codes that they use or how they store it, but it's that same general idea. All right, so next, talking about saving basic programs, there's some conventions on the file extensions that we use. File extensions are always optional on these systems. It helps us identify what a file is if you have these extensions. But as far as the kernel is concerned, it doesn't really care about extensions. But the most popular one is probably the .prg extension. When you see a .prg, it should always work with a load command. The exception there would be if the PRG was for a different system like a VIC-20 or a C64 or even original PET. Obviously that PRG wouldn't work for your system, the Commander X16 here. But still, within an X16 system, all the PRG files that you encounter, you should be able to load, whether it's a basic or machine code example. And then some people use a BAS extension, you know, for basic. But that becomes ambiguous on whether is it tokenized or plain text. You can't guarantee if it ends up being plain text, you can't use load to load that file. BAS is like in the MS-DOS world, the x86 worlds. When they're using QuickBASIC, a lot of those will be BAS files. One interesting note on the system, it was decided long ago, and I'm not sure who determined that. We could probably trace the code and figure it out, but someone for the auto boot, they used the X16 extension, which is interesting because it solves the problem with the PRG in that it is a PRG file, but it makes it obvious that it's for the Commander X16 system. So you can apply load to the auto boot or these X16 files. That convention, you know, hasn't really caught on for most of the developers on the Commander X16 as far as I've seen, but it's not a bad idea. Some other tips. You can use the BASLOAD keyword to load what we call a binary blob of 6502 code somewhere into RAM. Then you use the sys command to invoke that code, whatever address that you loaded it to. So if you're on a modern PC system and you have some assembler there that's created some binary code, you can use BASLOAD to load it right into RAM and run it. A lot of people will load it either into what's called the golden RAM, which we'll talk about memory map stuff later. Or another common place is on the banked memory at A000. Then BASLOAD, you know, it's called a binary load, but it can load text files all the same. And one advantage of that is if you BASLOAD a text file, then you can use the exec command to take that content from memory and stream it right into the basic interpreter on the system, as if like you had just typed that file or pasted it. In the emulator, of course, you can copy and paste things. So the exec command kind of allows that on the real physical hardware. So that's been real convenient. So another neat feature about the Commander X16 is it does have this ISO mode that a lot of the retro computer systems won't have. And ISO mode helps us interoperate with modern PCs a little easier. For one thing, you get the curly braces. And so that's nice. You hit Control O to enter the ISO mode, or you can programmatically enter or exit ISO mode using these characters, hex 0F and 8F. If you're out of ISO mode, then you have two character set options. You have the upper lower mode and then the upper graphics mode. The reason both of those, they actually originate from the Commodore PET. right around 1980 or the year before, there was kind of two versions of the PET. There was the graphic character model, and then there was a more professional one labeled as a CBM system or B model. And it was sold having this business character set, and it impacted not just the character set but also the keyboard that was delivered or packaged with those systems. They had different keycaps corresponding to the character sets that they offered. The original Commodore PET didn't have programmable character sets; they were in ROM. Um, Now we have the luxury in the Commander X16 is we have a variety of character sets that we can apply, and you can adjust those character sets to your liking also. You can toggle these two PETSCII modes using Shift Alt. Um, and even though PETSCII is historical, um, on the forums, Tony has replicated a lot of modern fonts. He's done a great job. It's like 100 fonts. It's a massive amount of fonts that he has available that a lot of people may enjoy using. So those are available. Check it out over on the forums. Um, just technical, just so you're aware, the standard ROMs are in ROM 6. System ROM slot 6, and on startup of the system they get copied over from that ROM over into VRAM. So that's why every time when you reset the computer, that's where those default set of ROMs fonts come from. And then after the system started up, you have to load up from the file system the new font that you want to use. All right, in a moment I'm going to resume the Commander X16 demonstration of exporting Tokenized BASIC over in the plain text. But just for reference, this is the set of commands that I'm about to show. But also note at the bottom, if you're using the emulator, there is a command line parameter that you can use to also help with doing that export. That may be a little bit easier if you're using an emulator. All right, now I want to convert this into the simple program, example program, over into BASLOAD. And the BASLOAD works with plain text. And so on system, this program is stored in memory in a tokenized form only. So it's a little artificial when you list. You're not really listing the contents of a file or um, a plain text version of this. The system just doesn't have enough memory to store the plain text version of this. Um, from the perspective of the early days of CBM systems, when you only had 4K or 8K of RAM. So in order to convert this over into plain text, one trick you can do is you open file number 8, device 8, file number 1, device number 8. Just give it some file name, and the S and W just means a sequential write. Then you do this command 1 as a keyword that lets you pipe whatever you have going to the console into that specified file number. So I'm going to do a list which lists the program, and you don't see anything on the console because it's now redirected that to that file name. To actually commit it, you have to do a print, close that file number. Now when I do a list, it's going back to the console again. And when I do F7 for a directory, you see my file has been created there. And now suppose I want to edit it. And so literally everything that was going to the console when I type list is now in this file. But now in order to convert it to BASLOAD, I have to get rid of these line numbers is the main first thing that I have to do. And any of this extraneous stuff before and after the program. So clear those out. That's easy. There is no automatic way to get rid of all these line numbers. You just have to go through and delete them. Now, you can use some scripting and some other exotic methods to kind of automatically get rid of those numbers. If that's a tool that you need, there may be one available in the forums. But generally, basic programs are just short. I just find it easier to just go ahead and cut off those line numbers manually. But now that I am in plain text, I'm kind of free to just adjust this program to make it look a little nicer. One thing you can do in BASLOAD, your variables can be longer than 2 characters. So I want to warn, okay, so I've just typed brace and underscore, and they look funny, right? Edit this program, this text editor built into the kernel, will open in the text mode that it was when you were in BASIC. And so since I was in PETSCII mode, it's still going to stay in PETSCII mode. So I can't type braces or underscores, or it doesn't appear that I can. I have to hit Control E and I have to switch over to the ISO mode. And now I can type those things and they appear as what I expect. And so that's pertinent because I want to do a go-to. You could leave things lowercase. I prefer to just go ahead and keep things uppercase. So again, you see I've typed an underscore, and I just want to run this program again. So kind of like in assembly, you can have labels followed by a colon, symbolic labels. You don't really have to worry about line numbers anymore. So when this program ends, I just want to automatically run it again. Another thing I might want to do is I want to clarify what this variable is doing. So like say degrees to radians, just spell it out a little bit more. I can space this, move this over. You know, I've got in old BASIC it was limited to like on some systems 40 columns. On the C64 and the X16, it's actually 80 columns. Here in BASLOAD, you know, it can go. You know, there's no real limit to a row length, but you still don't want to overdo it, just for the readability of the program. So let's just make sure this works. I save it back to the temp. I hit Control F to select the tool. I hit B for BASLOAD, and it says success. So what does that mean? You have to actually exit edit, and I do a list, and there's the program. Now it looks funny, right? What are these variables A that wasn't in my original program? And for the most part, it doesn't matter. What BASLOAD has done is it's taken all the variable declarations, whether they were 2 characters, 1 character, or a really long character, and automatically, you know, redirected them to variables in sequence. So it's going to start with A, then it goes to A0, and then somewhere in here should be an A1, and then A2. It's automatically going in sequence and managing that mapping for you of your 2-character variable over to whatever your long variable name was. So I don't really have to understand the program that BASLOAD has generated here. It basically has the form of the plain text version. At the end, you know, it goes back to run the program again. And if I run this, it runs the program, you know, in a loop as expected. So I hit run stop to stop it. I can go back to edit, open up my file. There's some control codes you can turn on. I'll explain that in a moment. You can add a symbol file. Okay, I'll open up what that looks like next. You can do AutoNum. So if you saw earlier, the line numbers in the BASIC program are sequential, 1, 2, 3, 4. If you want to do what most BASIC programs have in step by 10, so then you have some breathing room to add lines in between them. If you want to add some maybe debug statements, or maybe you just want to add a stop so you can kind of pause the program and probe memory values and such. Since I've turned on control codes, let's talk about that for a moment. Suppose right here you can do something like this. I want, I'll put these as yellow, and that's what control codes lets you do. You don't really have to remember what the PETSCII version of that, you can kind of just spell it out. And say down here, I want these as, let's see, cyan. Alright, so I save that, hit Control F, hit B for BASLOAD. Now I exit, and there, my program is now in units of 10. Instead of like white and red, it's now output, it's interpreted those control codes into whatever it's supposed to be for PETSCII. And I'll look at the symbol file in a moment. So I run this, there I've got some colors going on, hit run stop, and now I do edit. Good, it's made the symbol file. So the symbol file, nicely formatted. And here it's telling you what those variables, I had the P variable has been mapped to A, A0, A1, for this internal C variable. So if I need to know what, and this is the line those variables were declared on, that's nice. It'll do labels also. Here, the run again label, what line it's defined on, and what the physical line number is. It physically maps to line number 10. So that's all convenient that you have a little symbol file if you have more elaborate basic programs to help you debug. So that in a nutshell is BASLOAD. I'm going to switch over and talk about some memory map aspects of the system. And then we will convert an even larger program than this. Alright, let's talk about the memory map of the Commander X16 system, or really any CBM system, CBM-based system. I know it's a scary looking diagram. If you're not familiar with like decimal and hex, don't worry about that. The main point of this chart was to say why, or explain why BASIC is limited to the amount of memory that it's able to use. And we'll talk about how to get around those limitations. But for most of the 6502 base systems, they're going to all start with a 0 page. So even the Apple II has that set up. And there's a system stack at the next 256 bytes after that. And then there's like some system stuff. The kernel will use these regions of memory for things that it's handling. You know, the interrupt vectors are in there. On the PET, there was a couple tape buffers. On the Commodore PET, it had 2 tape decks that you could add to the system. And each of those was like 40 byte buffers, thereabouts. And a lot of people never used the second tape drive, so you could use that second buffer as your own RAM if you wanted to. Also on the PET, you know, their basic program started at 0400 instead of on the Commander X16, it's at 0800. So every system has some version of this memory map, and they may change over years of releases of those systems. So the Commodore 64 has a different, it's similar, but a different kind of memory map. And so when we talk CBM-based systems, this is part of what we're talking about, or one aspect. Another thing that makes a CBM system what it is also that look and feel of when you're using BASIC, and that you can move the cursor around, and it's got the quote mode. You move the cursor around to edit your programs, that kind of style. Now, one thing on the PET, you could more easily talk directly to the video. It was each character on the screen was mapped to a different address, and you know the Commander X16 doesn't work like that. You can't talk directly to RAM. You have to talk to the screen through these memory mapped I/O addresses to talk to the Vera. But BASIC takes care of all those details for you. You just type print, or you enter the graphics mode and you do a pset to start manipulating pixels. But then you can use peek and poke to kind of go outside of what we call your low RAM region, and that's how BASIC programs they get around that restriction. Because you have peek and poke, you can do some inline assembly, but you might poke that into what we call the golden RAM, this 1K buffer. Well, it's not really a buffer, this region, a 1K region, just slightly before where BASIC is. Now, you might have some, I think even edit, when you run edit, I think it uses small portions of the golden RAM. So when you have a couple programs running at the same time through interrupts, you know, maybe you have a background sound player or some kind of background utility, it might use portions of the golden RAM. And you just need to be aware of what those portions of RAM are. Some people will use golden RAM maybe to pass parameters from one program to another area. There's other ways to do that, but you can also use the bank RAM, where you can cycle in other 8K content as your program is running, and you can kind of slide in different portions of 8 kilobyte RAM. But they're all going to be at this address. BASIC is famous for kind of 2 main things, that it has line numbers and that you can do peek and poke in BASIC. But just from a historical aspect, I just wanted to emphasize that peek and poke weren't always in BASIC. It wasn't a fundamental thing from day one in BASIC. And there are reasons for that. When BASIC was developed in the mid-1960s, multi-user operating systems were being developed right at that time. Computers were so expensive, it was kind of unthinkable to have an idle computer. You always wanted to have users doing something on that computer. So they always, from the get-go, they built the systems to be multi-user from the beginning. And so peek and poke doesn't really work in that context. You can't really poke anywhere in the address space on those mainframe computers. You might interrupt other people's processes. It's sort of like the idea of a protected mode. Like when you run a process, you're assigned to your virtual addresses and your process space within the system. So peek and poke weren't in the original versions of BASIC. That idea of needing peek and poke came about more when personal microcomputers were being developed. So the earliest appearance of that idea of peek and poke is around some magazines, 1971, 1973, where it's being discussed in some documentation. But it became really a standard part of microcomputer BASIC, starting as early as the Altair BASIC from Microsoft, or what became Microsoft, starting in 1975. As you had an affordable single-user system, then it started to make sense where you have the whole address space, let them be able to poke values anywhere in that address space. It also solves this where maybe the system ROM, some new equipment comes along and you need to talk to some address port. So as you have new capability that wasn't envisioned in the original system ROM, peek and poke lets you at least start experimenting with those features. And then maybe the system ROM gets updated to incorporate those features if they pan out as being useful aspects. Corresponding with peek and poke is to make it really useful is you have to be able to do a sys, or some systems will call it a call, that lets you you poke some inline assembly and then you can sys that address and just run that assembly, and then come back to BASIC after that. So while we're discussing BASIC, at least on the Commander X16 or CBM derived BASICs, here's a few kind of rules or aspects about their implementation of BASIC. Non-string variables will use 5 bytes, and they're stored in a 40-bit floating point representation. There are some mainframes that did have double precision and single precision. They had different representation, but this 40-bit representation kind of became the standard, I think even in the BBC BASIC and microcomputers. The percent sign here means it's a 2-byte integer. There are some pros and cons to that. You don't really save memory space. It's still going to be stored as 5-byte, at least on this implementation of BASIC. One of the limitations, for example, I couldn't use a for loop when I declared a variable that type. But the format of it, when you can get a pointer to that address and you see numerical values started to be stored in what you would expect binary representation of a signed integer. And that is one of the cons, right? It is a signed integer. You can't have 0 to 65,000. You don't have an alternative way to go to an unsigned integer. Arrays, even though they have the different name, if they're typed differently, the fact that is an array is treated differently. You can consider it as if it's a different declaration than the non-array version. When you declare a string using this $ symbol, they are limited up to 255 characters. Those strings, you can concatenate them using this syntax. You access or view the contents of a string. It goes 1 to the length of that string inclusive. You use this keyword mid to get portions of the string. So if you just need to parse the first character, you would call mid the string that you want, and then 1, 1 to get the first character. If you need to know the length of a string, that's the keyword that you use. Arrays, before you use them, you have to statically declare the max size of those arrays. That pre-allocates memory in the basic address space for those arrays. You can have multiple dimensions on your arrays. There's no real max size to the array other than it's bounded by the amount of low RAM that you have. So that implicitly does put a bound on the size. but it's not really like number of arrays or the size of each dimension. You just multiply all these together, then multiply times 5 again, since each entry in the array is going to be 5 bytes. And that basically is, as long as it fits in basically 37K. But if you max size it, you know, for example, if you use 20K, then the rest of your program and data, you only have about 7K left for those allocations. So it's not clear cut to say what the max size of all your arrays. It kind of just depends on the size of each dimension in those arrays. And then this is the syntax to put values into that array. As we've discussed, the CBM basics, it's only 2 character variables. But some of the keywords like if and or, they don't count as variables. They won't be treated as variable storage. They are just interpreted as keywords in the basic parsing. Alright, so here's the longer example of a basic program, and I want to walk through how I convert this over into BASLOAD. And so as a typical basic program, it gets its inputs at the top, at the beginning. Then it does some processing on that input. In this case, it's a simulation of a projectile motion. And then it outputs some results at the end of that. Some highlights here, these go-tos. This is why BASIC is sometimes called spaghetti code. Right now we just have a couple go-tos, right? But if you visualize this, you get all these crisscrossing lines and it just looks like spaghetti going all over the place. When you start having dozens or hundreds of go-to statements all over the place, it gets harder to maintain. Obviously you have the line numbers, and so let's go on to the Commander X16 and convert this over into BASLOAD and start cleaning up and improving this program. Alright, for that longer program, I already have it typed in on the Commander X16, and we'll just load it. And when you load a program, so this little slash is a wedge utility to just load, and then whatever file it finds after that. But it's telling you exactly what address it's loaded at, and so that's why it's no mystery on what address we can start peeking to see the contents of that tokenized version of that program. So now I'll just list it there. So there's the program that we're talking about, and suppose we want to convert this over so we can start editing it in using BASLOAD. So using the trick that I showed earlier, we'll give it a name, overwrite temp text, sequential write, command file 1, then we'll list the program, then we'll basically flush, close that file. The program is still resident, but it is also should be exported now into this temp file. And so pretty long program, a lot longer than what we had earlier example. So Control K, get rid of a few lines at the top and the bottom here. Again, there's no easy way to get rid of all these line numbers. I'm just kind of have to manually start deleting them, but I do want to search and replace. You have a search and replace here in the edit. So S, it's Control S. And so what do I want to search for? I want to search all those lets, LETs. I want to get rid of them. I'll say all, yes. All right. Replaced 11 occurrences. Yep, that's the right count, because we don't need those. I'm going to divide the program from the input and these outputs here. Before you start getting rid of line numbers, okay, so this is important. We want to find, okay, so Control W to search, and what I search for is go-tos. And so I'm going to need line 200 later, I know that. So I prefix it with a L, and I go over to line 200, and I say L. Yeah, it's an RSL. Put a colon. I hit Shift L, and that actually put a pesky symbol besides that. Okay, so that one's important. And then search for another go-to. So here, line 200, and then somewhere down here, go to line 90. So now I know those are used and those are important. So I need to keep those as labels, and I use L just for label. L200. So now I get rid of whatever's left over. Keep the L label. And that's it. I can put this on the next line if I want to. Sometimes if it's a subroutine, I'll start indenting it. And keep the end. I can indent on the loops. This line 90. It can be on the same row. I mean, there's no problem with that. That's why labels work in BASLOAD. It's just treated as a compound, but it blanks it out where it's a null statement. I can indent those. That's just the place we're going to. I can keep the upfront initialization the same. I can put this on a different line if. Time max dim. Alright, so let's make sure. So I've modified it now all into BASLOAD. I could add control codes and all that kind of stuff, but I want to write it out, and instead of temp I'm going to say example. For me, these are the extensions I've been using on the BASLOAD source. I say BASLOAD and I do a text that just, when I switch over to the PC side and use the emulator, it's just easier for me to open up those text files. So that's why personally I put text at the end. I use BASL just to remind me that it's not a PRG, it is a plain text file for BASLOAD. So I'll save that. I'll do BASLOAD. It says success, so I exit and I do a list, and yeah, there's the whole program. So now I run it. I'll say 45 degrees, and I'll use the standard inputs. Okay, and it's calculated the projectile motion. Follow the numbers closely. Here, I'll even turn the mouse on and I can point to it. The numbers are increasing up to a certain point, the apogee of the projectile motion, then it starts coming back down and hits the ground at approximately 13 seconds. This is idealized with no winds, etc. and so on. So turn the mouse off. I can do an edit, bring my example back, and so let's go and do the fancy things. So control codes on, increment 10 between each of the line numbers, and let's go and turn on the symbol file. And just to make sure, before you run BASLOAD, do save it, and BASLOAD symbol file not allowed. I think before you do other control codes, you may have to do the symbol file first. So I'm going to cut that, put it back here, and let's try that again. Save it, and FB. Okay, success. All right, all that worked. I should be able to exit. I do a list, and there's my program in increments of 10. Let's look at the symbol file. Edit symbol. There I have my default labels and all of the variable declarations that are used in this program. If I need the components of the vector, they've been put over to A5 and A6. Alright, so I can edit again. Now that I have the BASLOAD version, I can change these labels to something more appropriate. End. When underscore isn't appearing right, I'm in the wrong ISO mode or character mode. So end. I'll just say end program. Yeah, I can change this one. Say next. Say next time. So now I have my labels defined. Test that. Nothing super impressive here. And list the program. It's really no change since I just updated the labels. Just run it to 4590. And yeah, so now I can start entering, say, graphics mode, and say I can graphically visualize these X and Y components. Another way to edit, if you don't have a lot of files, you can come up here and just say edit, press enter. So a lot of people do that, it's just faster. You don't want to do a rectangle. Then I'll just say the angle, hard code that to say 30 degrees, and the velocity, just put 80. I'll get rid of these. Now you have to think about the coordinate system on the graphics. So we've computed the 2 points here. I'm just going to guess. Label not found on line 29. I forgot the BASLOAD. So if you don't BASLOAD from edit, you can still apply the BASLOAD manually. It is just a command in BASIC. And it's parsed that and generated the program. So I run it. Yeah, it's going the wrong way. That's an increasing number, so I could say, let's say 200 minus that number. Surprisingly, the numbers increased larger, so maybe I need to say, you know, bring them down by a factor. Yeah. If you look at the values between the X and Y, yeah, you see that they get pretty large, larger than 320 by 240. So that's, it's wrapped around, so that should be 9 seconds, so there should be 9 dots on there. Maybe 10 was too aggressive. You could probably just, instead of 10, let's just do 4. See how that looks. Yeah, a little better. The text formatting is throwing it off also, but it's good that it's still showing it just for kind of a debugging purpose. We could update the T to get it a finer resolution, so that might be fun. Let's do that. So it has here the max T. Let's put it at 200. We don't really need to store these results, so I'm going to take that out and not store it here, which is going to break, you know, all of this. So we'll comment all of these out for now. We may come back to that. But the T here, instead of 1, let's go, I don't know, let's say 0.2. See what happens. Missed it. Run it. Yeah, that looks a lot nicer. Just increasing the resolution of the time. It looks like we need to run it longer. So this time max, now that I'm not storing it in an array, let's just, we'll go up to 1,000. And this time increment, let's just make it 1 now. And that, check that out. To move it lower on the screen, it should have been guess this. Yeah, that'll put it lower on the screen. And let's change, I don't know, let's go 50 degrees. Let's see how that looks. Oh, I forgot to BASLOAD it. Remember, you do have to apply BASLOAD. Okay, success. Let's run that. Yeah, check that out. So this is the kind of things BASLOAD can help you do. So you don't have to use, you know, this editor to start manipulating your program. I mean, this is you know, it's nice to reference, but you're going to maintain your program, you know, from here on out really in the BASLOAD form of it. If you do need to port this, I mean, you can take this code to other systems, maybe a C64 a little easier, and you can take along the symbol file also. That might help keep track of what these variables are doing, but for the most part, you're going to just maintain the program right here in BASLOAD itself. Alright, so that's it on just a little quick presentation about BASLOAD. It's a cool little feature that works directly on the Commander X16, built into the system ROM. Every system has it, and it's, you know, included in that price of the system. So I think it's a great value. Interesting way to approach BASIC, kind of in a more accessible and approachable way. So that's it. Thank you.
Mesdames, Messieurs,